We usually think of science as this perfect mirror, right? That it's just reflecting what's really out there. We imagine we discover things like gravity or thermodynamics, like we're just stumbling upon them, fully formed. But what if that's not quite the full picture? Okay, let's really get into this. This brings us to a huge, kind of mind-bending question. Is science a discovery or is it an invention? I mean, are we just finding the laws of nature that are already there? Or are we actively building the language, the framework, that even makes them visible to us in the first place? It might sound like a tiny difference in words, but trust me, it changes absolutely everything. So let's get on the same page. When we say discovery, we're talking about finding something that already exists, like finding a new island. Invention, on the other hand, is creating something new, something that wasn't there before. The whole debate really hangs on which one of these science is more like. Right, so we often picture scientists just kind of looking at the world, passively observing what's happening. But what if the very first thing they have to do, the most important first step, is to actually build the window they're looking through? Seriously, think about it for a second. Before you can run a single experiment, before you collect any data, before you can even make a meaningful observation, what is the one question that you absolutely have to answer first? And the answer is actually another question. How will I order the system? Now let's focus on that language. It doesn't ask, what is the system? It asks, how will I order it? That one little word, I, is the absolute key. It puts a human choice, a personal decision, right at the very, very beginning of the whole process. So, ordering a system, what in the world does that actually mean? Well, just picture the natural world for a second. It's messy. It's chaotic. Ordering means we, as humans, have to step in and impose some kind of framework on it. We literally draw a conceptual box around a tiny piece of that chaos and decide what matters and what doesn't. So how does this play out in the real world? Okay, imagine you're trying to study the gas in a room. First, you just observe the insane complexity. We're talking trillions of molecules bouncing around like crazy. That's step one. So what do? Well, step two, you have to define some boundaries. You make a choice to only look at the gas inside, say, a specific container. Then comes step three. You apply a framework. You decide you're going to describe it using human concepts, things like pressure and temperature. And it's only after you've made all of those choices that you can finally get to step four and actually start to measure something. And this just nails the crucial point. This initial ordering isn't just some boring first step we can rush through. It is the entire foundation of the house. Like the quote says, it's right there in the ordering that everything is established. Every piece of data you collect, every conclusion you draw, it all flows directly from that very first human decision. Okay, so let's zoom out a bit. If we're the ones building the very foundation of science, what's the bigger implication here? What does this mean for how we see nature itself? This is where it all starts to click. Nature itself, in its raw, unfiltered state, probably doesn't have these neat, tidy little systems and laws that we talk about. They aren't just lying around out there, waiting for us to find them with a label already attached. Which means our scientific models aren't a perfect photograph of nature. They're more like a human description, a statistical story that we tell from our own unique point of view, based entirely on the framework we chose to use from the beginning. And this brings us to that classic, brilliant saying, the map is not the territory. Our scientific frameworks are, without a doubt, the most incredible, useful, predictive maps humanity has ever created. But we can't ever forget that they're still just a map, a representation, not the wild, untamed territory itself. So what does this mean for something that feels as rock solid as the laws of thermodynamics? Well, it means they aren't nature whispering its secrets directly into our ears. They are an incredibly powerful and consistent story that we tell about nature. A story that works so well precisely because of how we decided to frame everything from the very start. So, right now, you might be thinking, okay, so what? Does this make science weaker? Is it all just made up? No, not at all. In fact, understanding this perspective actually helps us appreciate just how amazing science truly is. See, pointing out the human element doesn't mean science is wrong. What it means is that science is a tool. And it just might be the single most powerful tool we have ever invented. A tool built by humans, for humans, and perfectly tailored to our specific way of making sense of the universe. So let's wrap this all up. What's the big takeaway here? It's that science doesn't begin with a passive look at the world, but with an active human choice about how to look. That choice gives us a powerful map, but it's not the territory itself. It means that even our most fundamental laws are really descriptions from our chosen perspective. And that all leads to the most mind-blowing insight of all. We aren't just discoverers of knowledge, we are its co-creators.
And I want to leave you with this one last question to really chew on. If even something as fundamental and objective as physics is, at its very core, a human story we tell to make sense of the universe, what does that say about all the other things in our lives that we just take for granted as simple objective truths?